Okay, I'm going to go through the assignment here, question by question. Here, determine the value of x. X is this angle inside here, and we know that we've got a straight line on the bottom, which means that these two must add up to 180. We call them supplementary angles. So the supplement to 125 is whatever makes it add up to 180. So if we take away the part that we know, we take away this part here, we're left with our missing piece. So we take 180, subtract 125, we get 55. So all we're doing here is noticing that this is a straight line and these two must add up to 180. Next question, determine the value of x. How many degrees here? There are two things to notice here. One is that all angles have to add up to 180. So for a triangle, your angles add up to 180. And for an isosceles triangle, we see this mark here and this mark here. That means that these two sides are the same length, which also means that that angle and that angle are the same. So this angle here is 31. So if we take 180, which is the sum for all of the angles in this triangle, and we take away 31 for the right corner, and we take away another 31 for the other corner, so minus 31 minus another 31, we get 118. And just looking at this here, there's only one choice, even if I didn't do any math. This looks like an obtuse angle. And that's acute, that's acute, that's acute. There's only one of these that's actually obtuse. So without even doing a calculation, we'd have to choose B. Next, determine the value of x. X is just from here to here, not all the way around. But the same thing from the last triangle applies, which is for the big triangle here, this 25 degrees and that 25 degrees are equal because this is an isosceles triangle and these two are the same length. That means the angles at the base here are the same. So here I know that this is a 90. They tell me that's 90. So for this smaller triangle, I can take my 180 minus 90 from the right angle minus 25 from the other angle at the base. And if we take that, we get 180 minus 90 is 90, minus 25 is 65. This angle here is 65. 65, just looking at our other choices, these two are obtuse, and there's no way that's obtuse. It can't be because we already have a 90 in there. We can only have one angle 90 or greater in a triangle. And 25 is a possibility, although 25 looks a lot smaller than that. 25 looks like this, and this angle looks a lot wider. But at least we can narrow it down to these two without doing a calculation. Next, find the length of the diagonal in the square. Give your answer to one decimal place. The diagonal is across the square. If it's a square, then all four sides are the same length, and all the corners are 90 degrees. So that's useful to know. So we'll take a look at this as a right triangle, or that as a right triangle, but we'll take the bottom one here. So for a right triangle, where these two are the same length, that's 9 and that's 9. Then this is the longest side. The diagonal is the longest side, which has got to be our hypotenuse. The hypotenuse is always the longest side, and it's always opposite of the 90. So 81 plus 81 is 162. And if we take the root of 162, we get 12.7279, etc. A whole bunch of big, messy decimal places there. It says to one decimal place, so we'll give it as 12.7. And the unit was meters, so we'll say meters. Probably you just want to type in 12.7 if it's a numerical response. Next, which triangle is similar